Tonight, before you gently close your eyes, I'd like to invite you on a very special journey. Not to a distant planet, not to a brilliant galaxy, but to a place that seems almost completely empty, a vast expanse stretching between galaxies, where even light requires millions, sometimes billions of years to cross. For a very long time, humanity imagined the universe as a dark ocean, with galaxies drifting like lonely islands, suspended in an endless void. Yet one of the greatest discoveries of modern science has revealed a remarkably different reality. The space between galaxies has never truly been empty. Hidden within that profound stillness are streams of plasma heated to millions of degrees, enormous cosmic filaments connecting galaxies across unimaginable distances, ancient particles that have existed since the dawn of the universe, and countless mysteries that still await discovery. Perhaps this also offers us a beautiful reflection. In the psychology of Carl Gustav Jung, what is invisible is not the same as what does not exist. Just as the unconscious quietly shapes the thoughts and emotions of every human being, the seemingly empty space between galaxies silently influences the formation, evolution, and ultimate fate of the universe itself. This is not meant to compare science with psychology, but rather to remind us that the things we cannot see with our eyes are often the ones that possess the greatest power. In tonight's video, we'll explore more than 100 fascinating facts about intergalactic space. You'll discover why a region that is almost a perfect vacuum can reach temperatures of millions of degrees, how galaxies can actually steal matter from one another, what connects hundreds of billions of galaxies into an immense cosmic web, and why most of the universe's ordinary matter is not located inside galaxies, as many people assume. Each chapter will take us one step deeper into the grand tapestry of the cosmos, told at a slow, soothing pace so that you can learn, relax, and gradually drift into a peaceful night's sleep. Welcome to our channel, a place where stories about the universe, science, and profound reflections are told in a calm, gentle voice, helping you bring your day to a peaceful close with a sense of wonder. If you enjoy journeys of discovery like this one, we'd love for you to subscribe and turn on notifications so you won't miss our future adventures. Every video is an invitation to see the world through a wider lens and perhaps, along the way, to better understand yourself. Now, take a slow, deep breath. Let your shoulders relax. Allow the sounds of the day to gently fade away. And join me as we begin our journey into the quietest reaches of the universe, a place that appears to hold nothing but darkness, yet quietly preserves some of the greatest stories science has ever uncovered. Intergalactic space is not empty. If, at this very moment, you could leave Earth, drift beyond the moon, travel past the orbits of the planets, continue farther than the giant clouds of gas that surround our solar system, leave the Milky Way behind, and keep traveling for millions of light years, you might imagine that, at last, you had entered a place that is completely empty, a realm with no light, no sound, no stars, no planets, no life, only darkness, stretching endlessly in every direction. For centuries, this was exactly how humanity imagined the space between galaxies. Galaxies were thought to be like brilliant islands of light, scattered across a vast black ocean, separated from one another by immense regions of absolute emptiness. But modern science, just as it has done so many times throughout history, has gently invited us to reconsider what once seemed obvious. And gradually, an extraordinary truth began to emerge. The space between galaxies has never truly been empty. It is simply too vast, too diffuse, and too quiet for human eyes to perceive its presence. Perhaps there is something deeply meaningful about that. In life, not everything that is invisible is absent. We cannot see the wind, yet we know it is moving through the trees. Gravity, as novisible form, yet it keeps the planets in orbit around the Sunday. Love, memory, hope, none of them can be held in our hands, yet each has the power to transform a human life. The universe is much the same. Its greatest wonders are often the hardest to see. Today, thanks to powerful telescopes and space observatories, astronomers know that the space between galaxies is anything but empty. It contains unimaginably thin clouds of hydrogen gas, helium atoms forged during the very first minutes after the Big Bang, regions of plasma heated to millions of degrees, weak magnetic fields stretching across millions of light years, and countless high-energy particles quietly traveling through the cosmos. If we could somehow see all of these invisible structures, the empty space we once imagined would instead appear as an immense ocean, a transparent ocean, without waves, without color, yet always in motion, always changing, always connecting galaxies across the universe. Even more astonishing, for decades, scientists wrestled with one of cosmology's greatest mysteries. Where had all the ordinary matter in the universe gone? According to cosmological models, the amount of hydrogen and helium created after the Big Bang should have been far greater than the amount of ordinary matter observed inside stars and galaxies. This puzzle became known as the missing baryon problem. Gradually, observations made with X-rays, ultraviolet light, and the light from extremely distant quasars revealed the answer. Most of the universe's ordinary matter is not found inside galaxies at all. Instead, it is spread throughout the vast spaces between them, existing as extraordinarily diffuse gas. That means, when we gaze upon a brilliant galaxy shining in the night sky, we are seeing only the visible tip of something far greater. Much like an iceberg, the sparkling portion above the water never tells the entire story. The larger part remains quietly hidden beneath the surface. Perhaps that is one of the reasons the universe is so breathtaking. It continually reminds us that reality is often deeper than what our eyes can perceive. Every new discovery does more than expand our understanding of the stars. It also teaches us humility. It reminds us that within a universe so vast, it is almost beyond comprehension. Countless things continue to exist, even though we have never seen them. And perhaps that seemingly silent emptiness has been preserving the oldest stories in the universe all along. Stories that began when the very first light was born. Stories carried across billions of years, until, at last, they gently arrived at humanity's telescopes. Tonight, as you listen to these words, perhaps you can imagine yourself drifting slowly through intergalactic space. There is no sound, no sense of direction, only the faint glow of distant galaxies, floating like islands upon a cosmic sea. At first glance, everything appears perfectly still. But if you watch long enough, you begin to realize that even the quietest place in the universe is filled with the presence of matter, of energy, and of silent motions unfolding over billions of years. Perhaps the space between galaxies is not a symbol of emptiness at all. Instead, it is a reminder of a beautiful truth. The things that matter most do not always announce themselves with noise. Sometimes they simply exist, quietly, patiently, enduring through time until humanity learns to look a little deeper. And in the next chapter, we will explore something even more extraordinary. Why does a region that is almost a perfect vacuum contain an ocean of plasma heated to millions of degrees? Why are galaxies not drifting through empty space, but instead swimming through a vast sea of invisible matter, a cosmic ocean, whose existence humanity has only begun to understand in recent years? The invisible ocean between galaxies. In the previous chapter, we discovered that the space between galaxies has never truly been empty. Now, we take another step into one of the most extraordinary discoveries of modern astronomy. Imagine yourself quietly drifting away from the edge of a galaxy. The light of hundreds of billions of stars slowly fades behind you. Ahead, there is only an immense darkness stretching beyond imagination. By instinct, we might assume that such a place must be unimaginably cold, so cold that every form of motion has come to a halt, as cold as a shadow that has never been touched by light. And yet, once again, the universe surprises us. In many regions, the space between galaxies is not cold at all. Instead, it reaches temperatures of millions of degrees. At first, that sounds like a contradiction. How could a place that is almost a perfect vacuum, where only a handful of particles occupy an entire cubic meter of space, be hotter than the surface of many stars? The answer lies in how physics defines temperature. In everyday life, we experience heat through the amount of thermal energy transferred to our bodies. But in physics, temperature measures the average kinetic energy of particles. A region may contain very few particles, yet if each one is moving with extraordinary energy, its temperature can still be incredibly high. That is exactly what happens in intergalactic space. Hydrogen and helium atoms are bombarded by intense radiation from galaxies, quasars, and immensely energetic cosmic events. Their electrons are stripped away from their nuclei, creating a remarkable state of matter known as plasma. Plasma is often called the fourth state of matter. It is neither solid, nor liquid, nor an ordinary gas. Instead, it is a sea of electrically charged particles, constantly moving and interacting with magnetic fields. Perhaps even more fascinating, most of the visible matter in the universe actually exists in this state. From the blazing cores of stars, to the vast solar coronae, to the immense regions between galaxies, plasma is everywhere. If our eyes were capable of seeing it, the universe would no longer appear as a silent sea of darkness. Instead, it would reveal itself as an immense ocean of delicate light, great rivers of matter flowing slowly across millions of light years, surrounding galaxies like invisible cosmic currents. Today, X-ray observatories such as Chandra X-ray Observatory and XMM Newton have enabled astronomers to detect enormous regions of superheated plasma surrounding galaxy clusters. These regions emit faint X-rays, far beyond the range of human vision, yet they tell us the story of an invisible ocean that remained hidden for most of human history. This discovery has transformed the way we imagine galaxies. They are not standing motionless in empty space. They are moving like enormous ships silently sailing across a vast sea of invisible matter. And just as a ship interacts with the water through which it travels, a galaxy also interacts with the environment around it. When a galaxy plunges into the dense gas of a galaxy cluster, the pressure of the surrounding medium can gradually strip away its cold gas. Astronomers call this process Ram pressure stripping. The gas, the essential raw material for creating new stars, is pulled into long streams, trailing behind the galaxy. Over time, the galaxy slowly loses its ability to give birth to new generations of stars. Its light grows older, softer, more subdued, and eventually, it enters an entirely new stage of its evolution. Perhaps this reminds us of something profound. Even in the universe, no galaxy truly exists in isolation. Its surroundings, almost invisible though they may be, can quietly shape the destiny of hundreds of billions of stars. Carl Sagan once wrote in Cosmos, "We are a way for the cosmos to know itself." Perhaps those words speak about more than humanity alone. They remind us that every new discovery about the universe is also a discovery about the remarkable capacity of the human mind. For the deeper we look, the more we realize that nature rarely behaves according to our first intuition. What appears cold can be filled with blazing plasma. What appears perfectly still can conceal currents flowing across millions of light years. Perhaps the true beauty of science is not that it replaces mystery with numbers. Rather, every answer opens the door to an even greater question. If galaxies are swimming through an invisible ocean, how far does that ocean extend? If plasma surrounds entire galaxy clusters, what holds it in place? And if space is not truly empty, could the entire universe be connected by a structure far greater than anything human eyes have ever imagined? Tonight, as your eyelids grow heavy, perhaps you can picture yourself drifting peacefully through the quietest ocean that has ever existed. There are no waves, no shoreline, no wind, only immense galaxies, silently gliding through an invisible sea of plasma. Each galaxy carries hundreds of billions of stars. Each star may host worlds of its own, and together they all drift through an ocean whose existence humanity has only recently begun to understand. Perhaps the universe has never been a collection of lonely islands. Perhaps it is an immeasurable ocean where every galaxy is connected by quiet rivers of matter flowing through the depths of cosmic time. And in the next chapter, we will explore a structure even more magnificent than this invisible ocean of plasma, a colossal network stretching across the universe where galaxies are not scattered at random, but linked together by enormous filaments of matter, forming what scientists call the cosmic web, the largest known structure in the observable universe. The cosmic web. In the previous chapter, we drifted through the invisible oceans of plasma that surround galaxies. Now, let us journey even farther, beyond a single galaxy, beyond an entire galaxy cluster. Imagine pulling back so far that, for the very first time, we can see the universe as a whole. Perhaps, if you could stand at a distance great enough to observe the entire observable universe, the first thing that would astonish you would not be the sheer number of galaxies. It would be the way they are arranged. For a long time, scientists believed that galaxies were distributed almost randomly, like grains of sand scattered across an endless plain. But as astronomical surveys became increasingly detailed, especially through projects such as the Sloan Digital Sky Survey, an entirely different picture began to emerge. Galaxies are not scattered at random. They are connected, cluster by cluster, chain by chain, enormous filaments of matter, woven together into a network so vast that it almost defies human imagination. Astronomers call this extraordinary structure the cosmic web. It is the largest known structure in the universe. Not a single galaxy, not even a supercluster, but an immense network connecting hundreds of billions of galaxies through filaments of matter stretching across hundreds of millions of light years. Seen from a great distance, the cosmic web resembles delicate strands of a spider's web, or the tiny blood vessels that spread throughout the human body, or the roots of an ancient tree reaching silently through the earth. One of its most remarkable features is that wherever these immense filaments intersect, vast clusters of galaxies are born, and between those filaments lie enormous regions of apparent emptiness. Astronomers call them voids. At first, a void may sound unimportant, a region containing few galaxies, very little matter, nothing especially remarkable. Yet, just as silence gives meaning to music, or empty space gives balance to a painting, these immense voids are essential to the beauty of the entire cosmic structure. Some voids measure hundreds of millions of light years across. If the Milky Way happened to reside inside one of these enormous regions, our night sky would appear almost empty. Very few distant galaxies would be visible, not because they do not exist, but because they are simply too far away. Some rays of light require tens or even hundreds of millions of years to travel from one side of a void to the other. And throughout that extraordinary journey, they may pass without encountering a single galaxy. It is a realm of almost unimaginable silence. Yet that very stillness makes these regions priceless to science. In places containing very few galaxies, few stars, and few supernova explosions, the environment remains remarkably undisturbed. Ancient traces left behind from the earliest chapters of cosmic history can survive there far more intact. Astronomers often compare these intergalactic regions to ancient pages of a forgotten manuscript. They preserve memories of a time before the first galaxies had fully formed, when matter was only beginning to gather under the quiet pull of gravity. Perhaps the greatest beauty of the cosmic web does not lie in its size. It lies in its interconnectedness. Galaxies that appear lonely have never truly been isolated. Each one belongs to something much larger, linked to countless others through invisible streams of matter and the silent force of gravity. Perhaps that offers us a gentle reflection. In life, there are moments when we feel small, alone, like a solitary star in an endless sky. But when we step back and see a wider picture, perhaps every encounter, every memory, every kind word, and every act of compassion becomes another invisible thread, connecting us with one another, not unlike the filaments that connect galaxies across the universe. This is not a law of the cosmos that governs human life. It is simply a reminder that both in nature and in our own lives, invisible connexion can be just as important as the things we are able to see. Astronomer Carl Sagan wrote in Cosmos, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." Perhaps, when most people read those words, they think of the atoms within our bodies, forged long ago, inside ancient stars. But perhaps they can also be understood in a broader sense. When humanity studies the cosmic web, we are not merely observing the universe. In a way, the universe is gradually coming to know itself through curious minds and wondering eyes. Tonight, as you gently close your eyes, imagine yourself far beyond the Milky Way, so far away that our galaxy becomes only a tiny point of light. Then, that point becomes a single glowing knot upon a vast filament, and that filament joins countless others, woven together into a network so immense that its boundaries disappear beyond imagination. Perhaps what moves us most deeply is not simply that the cosmic web is unimaginably large. It is that, within such overwhelming vastness, everything remains connected through a quiet and elegant order, without noise, without spectacle, simply existing silently for nearly 13.8 billion years. And within that immense network, galaxies do far more than merely coexist. They meet, they collide, they exchange matter, they quietly reshape one another's destinies over billions of years. In the next chapter, we will witness some of the universe's most dramatic encounters, where giant galaxies do not simply glide past one another, but are torn apart by gravity, stripped of their gas, stretched into magnificent streams of stars, and sometimes even fling entire planetary systems into the vastness of intergalactic space. It is the story of battles fought in absolute silence, yet powerful enough to shape the very universe we see today, the silent wars of galaxies. In the previous chapter, we explored the immense cosmic web, the vast network that connects hundreds of billions of galaxies into a single grand structure. Now, we turn to another remarkable truth. Although the universe appears profoundly peaceful from afar, beneath that silence, dramatic transformations have been unfolding for billions of years. These are not wars in the human sense of the word, but slow, graceful dances, choreographed by gravity, powerful enough to reshape the destiny of entire galaxies. Perhaps, when we hear the word collision, we imagine violent explosions, flying debris, head-on impacts. But in the universe, encounters between galaxies unfold to an entirely different rhythm. Each galaxy spans hundreds of thousands of light years. Within them, the stars are separated by unimaginably vast distances. So when two galaxies draw close, the most likely outcome is not that their stars crash into one another. Instead, their immense gravitational fields to begin to stretch and distort each other's structure. Like two mighty rivers flowing side by side, they do not need to collide violently to change the course of both streams. One of the most fascinating processes is known as tidal stripping. The name may sound complicated, yet the phenomenon itself is surprisingly elegant. As one galaxy passes another, gravity pulls more strongly on the side that is closer than on the side that is farther away. That subtle difference gradually draws away clouds of gas, dust, and even stars from their original positions, little by little, over hundreds of millions of years, until magnificent streams of matter, stretching across hundreds of thousands of light years, appear in space. These breathtaking structures are called tidal tails. If our eyes could see them directly, they might resemble long ribbons of glowing silk drifting silently through the darkness. Their beauty is almost impossible to describe, yet it is a beauty created by the quiet work of gravity over billions of years. It is not only gas and dust that can be carried away. Sometimes, entire stars are torn free from their home galaxies. They become intergalactic stars, wanderers, drifting through the vast spaces between galaxies, no longer orbiting the center of any galaxy, traveling alone, carrying only their own light. Perhaps the thought of a star without a home sounds lonely, yet within the universe, it is simply another chapter in the natural story of cosmic evolution. Galaxies are not permanent. They are born, they grow, they encounter one another, they exchange matter, and over time, they transform. What is even more remarkable is that if a star is pulled away from its galaxy, the planets orbiting that star are likely to accompany it. Imagine, for a moment, a planet much like Earth. It circles its familiar star. Every night, its sky is filled with countless stars. Then, over millions of years, a gravitational encounter slowly carries that entire star system out of its home galaxy. The familiar heavens begin to disappear. The bright band of the Milky Way fades away. The billions of surrounding stars are gone. Only a profound darkness remains, broken by a handful of distant galaxies, their faint light almost beyond imagination. Some worlds may experience an even stranger fate. If gravity is strong enough, a planet itself can be torn away from its parent star. It becomes a rogue planet, a world without a sun, no sunrise, no sunset, no familiar seasons, only an endless journey through the cold darkness of interstellar or even intergalactic space. At first, that sounds deeply lonely, yet science offers another intriguing possibility. Some rogue planets may continue to generate internal heat through radioactive decay or ongoing geological activity. If oceans of liquid water exist beneath thick layers of ice, then, at least in theory, such worlds could still deserve careful study as potential environments where life might persist. Perhaps this reminds us that even in the places that seem most isolated, nature continues to leave open possibilities that humanity has not yet fully explored. Astronomer Carl Sagan wrote in Pale Blue Dot, "The universe seems neither benign nor hostile, merely indifferent." Perhaps that is one of the most comforting thoughts science has ever offered. The universe does not reward. It does not punish. Galaxies do not meet because of anger. Stars are not cast away. By intention, everything unfolds according to the same laws of physics that have governed the cosmos for nearly 13.8 billion years. And within that cosmic indifference, something unexpectedly beautiful emerges. Graceful spiral galaxies, immense tidal streams, new generations of stars, and solitary rogue planets silently wandering through the darkness. Tonight, as you gently close your eyes, imagine yourself standing upon a distant world that belongs to no galaxy at all. The brilliant river of the Milky Way no longer stretches overhead. Only an endless darkness surrounds you. Far away, a single galaxy appears as a faint island of light, beautiful, peaceful, and almost unchanged across millions of years. Perhaps it is the quietest place the human imagination can ever reach, and perhaps it gently reminds us that in the universe, change does not always arrive with noise. The greatest transformations are often shaped by invisible force, working patiently, silently, across billions of years. Yet from these quiet encounters, galaxies gradually gather into families of their own, small communities bound together by gravity, traveling through the cosmos as one. In the next chapter, we will leave behind these immense cosmic interactions and journey closer to home, exploring the local group, the galactic family of the Milky Way, where our galaxy is far from alone, sharing its corner of the universe, with dozens of neighboring galaxies, all drifting together through the boundless cosmic ocean. The Milky Way's galactic family. In the previous chapter, we witnessed the slow yet transformative encounters between galaxies. Now, let us journey a little closer to what we call home, for amid the vast cosmic ocean, the Milky Way has never been alone. It has neighbors, companions, and an entire galactic family that has quietly traveled together for billions of years. Perhaps, when we look up at the night sky, we naturally imagine the Milky Way as the center of the story, the most special place, the only home we have ever known. But the more deeply humanity has explored the universe, the more we have come to realize that even our own galaxy is simply one member of a much larger community. The Milky Way is not standing still. It is racing through space at hundreds of kilometers per second, carrying with it hundreds of billions of stars, vast clouds of gas, glowing nebulae, countless planets, and our own solar system. What is remarkable is that throughout this incredible journey, the Milky Way has never traveled alone. It belongs to a collection of galaxies known as the local group. This is a gravitationally bound family of more than 100 galaxies, large and small. If the cosmic web is like the universe's vast network of highways, then the local group can be imagined as a quiet neighborhood where galaxies are neighbors, sharing the same region of space, traveling together, influencing one another, and quietly writing their shared story over billions of years. Within this galactic family, the two most prominent members are the Milky Way and the Andromeda Galaxy. Andromeda is the largest spiral galaxy. In the local group, it lies about 2.5 million light-years away. If the sky is dark enough, far from the glow of city lights, the human eye can still glimpse Andromeda as a faint, misty patch of light. That means the light reaching your eyes tonight left Andromeda long before the earliest human ancestors ever walked the Earth. Every time we look at Andromeda, we are looking into the distant past. Alongside Andromeda is another important member of our galactic family, the Triangulum galaxy. Smaller, yet still a vital part of the local group. Together, these three large galaxies, along with dozens and ultimately more than 100 smaller galaxies, form a delicate gravitational family held together by the quiet pull of gravity. Perhaps what fascinates astronomers most is not the existence of the giant galaxies, but the importance of the smallest ones. These are the dwarf galaxies. At first glance, they may seem insignificant. Small, Jing, containing far fewer stars than the Milky Way. Yet, just as a single pebble can tell the story of an entire mountain, dwarf galaxies preserve remarkable clues about the universe's earliest history. Many astronomers believe that large galaxies did not form all at once and remain unchanged. Instead, they grew by gradually absorbing smaller galaxies over billions of years. The Milky Way itself has experienced many such encounters. Its gravity stretched nearby dwarf galaxies, tore them apart, and transformed them into long rivers of stars that slowly merged into our own galaxy. Even today, those ancient stellar rivers still circle the Milky Way, quietly tracing paths that have endured for billions of years. Astronomers call them stellar streams, the lingering remains of ancient galactic mergers. To modern telescopes, they are like cosmic fossils, preserving the history of events that unfolded billions of years ago. Perhaps no book could ever record the complete story of the Milky Way, yet these quiet streams of stars continue telling its history, chapter by chapter, patiently, faithfully, and honestly. Perhaps that offers us a gentle reflection. In life, they too are shaped by the people we meet. Some remain beside us for many years, others appear only briefly, yet every encounter leaves behind a trace, quietly contributing to the people we eventually become. This is not a law of astronomy applied to human life. It is simply a reminder that both the universe and human experience carry layer upon layer of history slowly built through time. Carl Sagan wrote in Cosmos, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." Perhaps whenever we gaze at the Milky Way, we think we are simply looking up at the night sky. But in another sense, we are also looking toward our own beginnings. The atoms that make up our bodies were forged inside ancient stars. Those stars belonged to galaxies. Those galaxies belong to the local group, and the local group itself is only a tiny knot within the immense cosmic web. Tonight, imagine yourself far enough away to see both the Milky Way and Andromeda suspended against the darkness of space. Two magnificent rivers of light slowly drifting toward one another, without urgency, without noise, only the patient motion of billions of years. Around them, their countless dwarf companions continue orbiting faithfully, like quiet travelers sharing the same journey. Perhaps In a universe that seems almost infinite, there is something deeply comforting in knowing that even the Milky Way has a family and has never truly been alone within the darkness. Yet within that very family are some of the universe's most extraordinary wanderers, stars that no longer belong to any galaxy and planets that travel without a sun to call their own. In the next chapter, we will leave behind the familiar galaxies and meet the loneliest travelers in the cosmos, homeless stars and wandering planets, drifting through intergalactic space, where the darkness stretches almost without end, yet still holds possibilities that continue to astonish scientists to this day. Homeless stars. In the previous chapter, we discovered that the Milky Way is only one member of the vast family known as the local group. Now, let us leave those familiar neighborhoods behind and meet some of the loneliest travelers in the universe, celestial wanderers that no longer belong to any galaxy, no longer orbit any familiar center, yet continue their silent journey through the immeasurable darkness between galaxies. Perhaps, in everyday life, we naturally assume that every star belongs to a galaxy, that every planet must orbit a sun, just as every river eventually finds its way to the sea. But once again, the universe reminds us that nature is always more expansive than our imagination. Within intergalactic space, astronomers have discovered intergalactic stars, stars that are no longer gravitationally bound to any galaxy at all. Most of them once belonged to galaxies, but after gravitational encounters, lasting millions or even billions of years, they were gradually pulled free, set adrift, and continued their journey, carrying nothing but their own light. If you could stand beside one of these wandering stars, perhaps you would no longer see the brilliant river of hundreds of billions of neighboring stars that fills our own night sky. Instead, the heavens would be far darker. In the distance, only a handful of galaxies might appear as faint islands of light, beautiful, yet so unimaginably distant that they would seem forever beyond reach. Nor are stars the only travelers. Entire planetary systems may accompany them. When a star is pulled from its home galaxy, the planets orbiting it are likely to remain faithful companions. An entire solar system, like a solitary ship drifting quietly across the endless ocean of intergalactic space. Yet, the universe holds something even stranger. Some planets lose not only their galaxy, but even their parent star. Astronomers call them rogue planets, wandering worlds. Once they circled a familiar sun. Once they followed stable orbits, but powerful gravitational interactions threw them into the darkness, where they began a lonely voyage lasting billions of years. Imagine standing upon such a world. There is no sunrise, no sunset, no daylight. The sky is forever dark. Only distant galaxies and a few faint stars glimmer like scattered grains of dust across an endless night. At first, it may seem like the coldest, loneliest place nature has ever created. Yet here, science offers another extraordinary possibility. Not every source of warmth comes from starlight. Some rogue planets may continue to generate internal heat through radioactive decay or slow geological activity deep within their interiors. If a thick shell of ice covers the surface, that frozen layer could act like an enormous blanket, trapping the heat below, and beneath it, perhaps, there could still be oceans of liquid water, silent, completely dark, yet not necessarily lifeless. Today, scientists continue investigating whether such environments might support simple forms of life. There is currently no evidence that life exists on rogue planets, but theoretical models suggest that they remain promising places to continue exploring. Perhaps this reminds us that life itself may be far more adaptable than humanity once imagined. Perhaps we instinctively associate light with life and darkness with endings, yet nature does not divide reality so simply. Even where starlight never reaches, unexpected possibilities may quietly unfold. Carl Sagan once wrote in Pale Blue Dot, "Look again at that dot. That's here. That's home. That's us." Those words were originally written while contemplating Earth from an immense distance, yet they also invite another gentle reflection. In a universe that stretches almost beyond comprehension, perhaps home is defined by more than location. Perhaps it is also defined by connection. Intergalactic stars, rogue planets, though they no longer belong to any galaxy or any solar system, they remain part of the same universe. They obey the very same laws of physics that govern Earth. They are built from atoms forged inside ancient stars. Perhaps that realization makes the boundary between the familiar and the unknown feel a little smaller. Tonight, imagine yourself standing upon a rogue planet. There is no sunrise, no moon, no blue sky, only profound darkness. Far away, a single galaxy appears as a delicate ribbon of light, beautiful, not because it is close, but because it is impossibly distant. Would you feel loneliness or peace? Perhaps within such an immense universe, those two feelings are sometimes remarkably alike, and perhaps it is in the places that seem most isolated that we learn to recognize the quiet beauty of simply existing. For the universe has never promised that every world would have a permanent home, yet it continually reminds us that even its loneliest travelers remain indispensable part of the greatest story the cosmos has ever told. As we leave behind these homeless stars and wandering worlds, our journey continues towards something even more mysterious. Immense oceans of plasma surrounding entire galaxy clusters, holding more ordinary matter than all the stars combined, and serving as one of the universe's greatest reservoirs of visible matter. Perhaps it is within those invisible oceans that we will finally understand why the space between galaxies has never truly been empty. The vast plasma seas surrounding galaxy clusters. In the previous chapter, the myth stars that no longer had a home and wandering planets drifting through endless darkness. Now, let us venture deeper still into the space between galaxies. This time, what awaits us is neither another galaxy nor another shining star, but an invisible ocean, so immense that it envelops entire clusters of galaxies. Perhaps, when we look up at the night sky, we naturally assume that stars make up most of the universe. After all, they shine, they capture our attention, they create the beauty of the night sky. Yet, as so often happens in nature, what stands out the most is not always what exists in the greatest abundance. Today, thanks to space-based X-ray observatories, astronomers know that many galaxy clusters are surrounded by enormous halos of superheated gas. This gas is nothing like Earth's atmosphere. It is astonishingly diffuse, almost a perfect vacuum, yet its temperature can reach tens of millions of degrees Kelvin. At such extreme temperatures, atoms can no longer hold on to their electrons. Matter enters the extraordinary state known as plasma. This is the most common state of matter in the universe. Unlike solids, liquids, or ordinary gases, plasma consists of freely moving ions and electrons carrying immense amounts of energy. Their motion causes the plasma to emit X-rays, radiation, completely invisible to human eyes. If our vision extended into the X-ray spectrum, the night sky would appear entirely different. Galaxy clusters would no longer resemble mere collections of brilliant points of light. Instead, they would be surrounded by vast glowing clouds, soft, luminous, and expansive, like enormous halos, embracing entire regions of space. Perhaps the most astonishing discovery is not their beauty, but their mass. In many galaxy clusters, the hot plasma contains more ordinary matter than all of the stars combined. In other words, everything we see in visible light is only the surface of the story. Most ordinary matter, known as baryonic matter, exists instead as invisible, superheated gas quietly surrounding galaxies, like an immense cosmic ocean upon which the bright islands of galaxies appear to float. For decades, astronomers puzzled over the mystery of the missing baryons. Cosmological calculations predicted far more ordinary matter than telescopes could actually detect inside galaxies and stars. Today, thanks largely to X-ray astronomy, much of that mystery has finally begun to unravel. These glowing seas of plasma contain much of the ordinary matter that had remained hidden for so long. Perhaps that is one of science's most beautiful lessons. Nature was never hiding its secrets. We simply did not yet possess the right eyes to see them. For centuries, humanity observed the heavens using only visible light. Then we learned to explore through radio waves, infrared, ultraviolet, gamma rays, and especially X-rays. Each new window revealed an entirely different universe. Reality itself never changed. Only our ability to perceive it continued to grow. Physicist Richard Feynman once said, "I think it's much more interesting to live not knowing than to have answers which might be wrong." Perhaps that spirit has guided modern astronomy from the very beginning. Scientists did not simply assume that empty space was truly empty. They kept asking questions, kept observing, kept building better telescopes, and gradually, layer by layer, the universe revealed its hidden stories, not through certainty, but through patience, humility, and an endless curiosity. Tonight, as your eyes slowly close, imagine yourself drifting gently within a galaxy cluster. Around you are not only spiral, galaxies, and giant ellipticals, but also an immense ocean of invisible plasma, transparent, colorless, odorless, invisible to ordinary sight, yet filling much of the space around you. Electrons, ions, moving silently, emitting X-rays that only space telescopes can perceive. Perhaps, without those invisible oceans, humanity would still believe it understood most of the universe's ordinary matter, yet those unseen seas quietly remind us that knowledge always stretches toward another horizon. Every discovery is simply another doorway, leading to an even deeper question, there is something deeply beautiful about that thought. The more we learn, the more we discover how much remains unknown, not as a reason for disappointment, but as an invitation to continue wondering, to continue learning, and to continue listening to the stories the universe tells through the language of light. Yet if these immense plasma oceans are often too faint to observe directly, how do astronomers map the remaining ordinary matter throughout the universe? The answer lies in some of the brightest beacons ever discovered, objects so luminous that their light travels billions of light years, carrying with it the fingerprints of every cloud of gas along its journey. In the next chapter, we will meet quasars, the universe's cosmic lighthouses, and discover how their brilliant light allowed astronomers to trace delicate filaments of hydrogen gas, decode the mysterious Lyman alpha forest, and gradually recover the missing ordinary matter that the universe had hidden for nearly 13.8 billion years. Quasars, the flashlights of the universe. In the previous chapter, we explored the invisible oceans of plasma surrounding galaxy clusters and discovered that most of the universe's ordinary matter does not shine at all. Naturally, another question follows. How can humanity observe clouds of gas that are almost completely invisible? How do we know they exist when they are far too faint to reveal themselves directly? The answer comes not from seeing the gas itself, but from the brightest cosmic beacons ever discovered, quasars, whose extraordinary light travels across billions of light years, illuminating everything along its path. Perhaps, imagine standing in the middle of the ocean on a moonless night. There is no shoreline, no nearby light, no familiar landmark. The only way to notice a veil of mist hanging in front of you is when the beam from a distant lighthouse passes through it. You do not see the mist itself. You see how it changes the light. Modern astronomy works in much the same way. Sometimes, to discover what cannot be seen, we do not observe the invisible object itself. We observe the traces it leaves behind, scattered throughout the universe. Are objects so extraordinarily luminous that their light can travel for billions of years before finally reaching Earth? These objects are known as quasars. Despite their appearance, a quasar is not a star, nor is it an ordinary galaxy. It is the intensely active core of a distant galaxy where a supermassive black hole is consuming matter at an astonishing rate as gas and dust spiral inward. Through the black hole's accretion disk, they are compressed and heated to extraordinary temperatures, releasing more energy than hundreds of billions of stars combined. For a time, a quasar can become one of the brightest objects in the entire universe. Yet perhaps its greatest wonder is not its brilliance, but the incredible journey of its light. The light from a single quasar may spend billions of years crossing the cosmos before arriving at a human telescope. Along that immense journey, it passes through countless clouds of hydrogen gas floating between galaxies. Each time the light passes through one of these clouds, a tiny fraction is absorbed at very specific wavelengths by hydrogen atoms. When astronomers analyze the quasar spectrum, they discover hundreds, sometimes thousands, of delicate dark lines stretching across the spectrum. This remarkable pattern is known as the Lyman alpha forest. At first glance, they appear to be nothing more than thin lines on a graph, But to astronomers, each one is like a footprint. Each dark line reveals where the light passed through. A cloud of hydrogen, how far away that cloud is, how fast it is moving, and the physical conditions within it. By reading those countless tiny signatures, scientists can construct maps of enormous clouds of gas that no human eye could ever see directly. Perhaps this is one of science's most beautiful ideas. Light does not merely reveal objects that shine. Sometimes it teaches us to recognize things that remain invisible. For decades, cosmologists faced one of the universe's greatest mysteries. Calculation, based on the Big Bang, predicted far more ordinary matter than astronomers could actually observe inside stars and galaxies. It became known as the missing baryon problem. Today, thanks to the light of distant quasars combined with ultraviolet and X-ray observations, scientists have located most of those missing baryons. They had never disappeared. They were simply spread throughout intergalactic space, existing as extraordinarily diffuse gas, far too faint to observe directly. Perhaps that offers a gentle reminder. In nature, some things are never truly lost. They simply wait for a new way of seeing. Carl Sagan once wrote in Cosmos, "Somewhere, something incredible is waiting to be known." Perhaps no words capture the story of quasars more beautifully. For billions of years, their light has continued its silent journey, never knowing that on one small planet, a curious civilization would someday learn to read the messages it carried. Every photon that reaches our telescopes is like un ancien lettre written near the dawn of cosmic history, traveling patiently through time to tell us about places no human being has ever visited. Tonight, as you close your eyes, imagine yourself floating through intergalactic space. Far away, a brillant quasar shines like a lonely lighthouse. In an endless night, its light passes slowly through delicate clouds of hydrogen, each encounter leaving behind the faintest possible signature, almost invisible. Yet when all of those tiny marks are assembled, they become a map of an enormous region of the universe. Perhaps that is also how knowledge itself is built, not from a single discovery, but from countless small clues patiently gathered across generations. And like the light of a distant quasar, the search for truth has never been a short journey. Perhaps that is exactly what makes every answer so precious. Through those beams of light, traveling billions of light years, humanity gradually discovered that galaxies are not scattered randomly through space. Instead, they are arranged within a far greater network shaped by dark matter and immense rivers of cosmic material. In the next chapter, we will step back farther than ever before to observe the largest structures in existence, where the cosmic web, its filaments, its superclusters, and its immense cosmic voids come together to form the grandest portrait modern science has ever painted of our universe, the largest structures in the universe. In the previous chapter, we followed the ancient light of distant quasars, using it to uncover nearly invisible clouds of gas between galaxies. Now, let us journey even farther away. So far, that individual galaxies begin to disappear, revealing instead a magnificent cosmic tapestry woven from hundreds of billions of galaxies, vast rivers of matter, and immense regions of emptiness. Here, the universe appears not as isolated objects, but as a single, interconnected whole where every galaxy is only one tiny thread within a structure far beyond human imagination. Perhaps one of the discoveries that astonished astronomers most deeply was not that the universe is unimaginably large, but that it is not chaotic. At first glance, galaxies appear to be scattered randomly through space. Yet the more carefully scientists observed, the more they realized that beneath that apparent randomness lies an extraordinary order. Interestingly, the idea of the cosmic web first emerged not through observation, but through theory, when cosmologists used powerful computers to simulate the evolution of the universe. After the Big Bang, matter did not collapse into isolated spheres. Instead, gravity gradually pulled it into enormous filaments, stretching, branching, and connecting into a vast network. At first, this existed only inside mathematical equations, but years later, large-scale galaxy surveys revealed that the real universe looked astonishingly similar to those predictions. It became one of the most beautiful moments in the history of science when mathematics, physics, and observation all converged upon the same truth. Within the cosmic web, the immense strands of matter are called filaments. These invisible highways contain far more gas, dust, and galaxies than the surrounding regions. If our eyes could truly see them, perhaps the universe would resemble an ancien forest. The filaments would become branches, galaxy clusters, its great intersections, and between them, vast voids would stretch like quiet lakes, almost empty, of galaxies. Where several filaments meet, even larger structures take shape. These are superclusters, enormous collections containing hundreds, sometimes thousands, of galaxies bound together by gravity. Our own Milky Way belongs to one such structure. Yet perhaps the greatest wonder lies within something we cannot see at all. Today, astronomers believe that the framework of the cosmic web is not built from ordinary matter, but from dark matter. We still do not know exactly what dark matter is. It neither emits, absorbs, nor reflects light, yet its gravitational influence is found everywhere. Its invisible network creates immense gravitational valleys, drawing in hydrogen and helium, formed after the Big Bang. Over billions of years, the gas collected, compressed, and eventually gave birth to the first stars and the first galaxies. In many ways, dark matter resembles the hidden framework inside a great building. We cannot see it, yet the entire structure depends upon it. Remarkably, everything began with unimaginably small differences. Shortly after the Big Bang, the universe was almost perfectly uniform, but not completely. Some regions contained just slightly more matter than others. Those tiny fluctuations, amplified by gravity over billions of years, gradually became filaments, superclusters, galaxies, stars, and eventually planets, like Earth. Perhaps this offers another beautiful lesson. Nature's greatest transformations often begin with differences so small they are almost invisible. Richard Feynman once said, "Nature's imagination is so much greater than man's." Perhaps Nos Quotations captures the cosmic web more perfectly. Human beings could imagine cities, bridges, and magnificent monuments. Yet nature, starting only with tiny ripples in the newborn universe, patiently wove a network stretching across billions of light years on la structure that required nearly 13.8 billion years to emerge. Tonight, imagine yourself far beyond every galaxy, beyond every galaxy cluster. Before you, there are no longer isolated points of light. Instead, a vast luminous network extends across the universe. Filaments curve like endless rivers. Superclusters shine like distant cities beneath a midnight sky. Immense voids rest in perfect silence like lakes without a ripple, and beneath it all, an invisible framework of dark matter quietly supports the entire universe. No one can see it, yet everything moves according to the paths it has shaped. Perhaps the greatest wonder of the cosmic web is not its unimaginable size. It is the realization that throughout the universe, connection exists on levels far deeper than human eyes can perceive. Every galaxy, every cluster, every cloud of gas, all belong to a story far greater than themselves. A story that began with the tiniest ripples after the Big Bang, and those ancient ripples will now carry us back to the very dawn of time itself. In the next chapter, we will journey to the universe's earliest ages, when the first clouds of hydrogen filled space, the first stars burst into existence. The era of cosmic reionization made the universe transparent, and the first light began its extraordinary journey across billions of years, until finally it reached our eyes. Today, the dawn of the universe. In the previous chapter, we stepped back far enough to witness the immense cosmic web supporting hundreds of billions of galaxies. Now, let us journey not only across space, but backward through time itself, not by millions of years, not even by billions of years. We are traveling almost to the very beginning of everything, a time before the Milky Way, before the Sun, before Earth, and before there were any eyes to gaze upon the stars. There was only a young universe, quietly beginning to write the opening chapter of a story that has unfolded for nearly 13.8 billion years. Perhaps, if we could return to the dawn of the universe, the first thing that would surprise us would not be light, but darkness. After the unimaginably energetic moments following the Big Bang, the universe gradually cooled. Protons and electrons combined, forming the first hydrogen atoms. A small amount of helium also came into existence. Throughout space, hydrogen spread like a delicate mist, blanketing nearly the entire cosmos. There were no galaxies, no planets, no stars burning with nuclear fire, only an immense ocean of hydrogen, silent, boundless, patiently waiting. About 380,000 years after the Big Bang, something extraordinary happened. The universe had cooled enough that light was no longer scattered by countless free electrons. For the first time, photons were free to travel. Those very photons continue their journey To this day, we know them as the cosmic microwave background, or simply the CMB. In many ways, it is the oldest photograph humanity has ever obtained of the universe. Whenever specialized telescopes observe the CMB, they do not see stars or galaxies. Instead, they reveal the faint imprint of a universe still in its infancy. It is like opening an old family album and discovering the very first photograph of a newborn child. What makes that ancient image so remarkable is that it is not perfectly uniform. Some regions are only a few millionths of a degree warmer or cooler than those around them. At first, those tiny differences seem insignificant. Yet from those delicate ripples, gravity began its patient work. Hydrogen slowly gathered together, little by little, across tens, then hundreds of millions of years, until finally the first stars burst into existence. For the first time, the universe had lights of its own. Their brilliance did more than illuminate the darkness. It began to transform the universe itself. Powerful ultraviolet light from those first stars stripped electrons away from neutral hydrogen atoms, turning them back into ionized gas. Astronomers call this era the epoch of reionization. It marked one of the greatest turning points in cosmic history. The ancient hydrogen fog gradually disappeared. Space became increasingly transparent. Light could now travel across enormous distances. The first galaxies began to emerge, and the universe slowly acquired the appearance we recognize today. Perhaps without this great era of reionization, we would never have seen the most distant galaxies. Their light would have remained trapped forever within the ancient cosmic mist. One of the most beautiful truths about astronomy is that every time we observe a distant object, we are also looking backward through time. Light never arrives instantly. Sunlight takes about 8 minutes to reach Earth. Light from the Andromeda galaxy travels about 2.5 million years. The light from the most distant galaxies began its journey more than 13 billion years ago. In other words, a telescope is not merely a machine for exploring space. It is also a machine for exploring time. Every image of a distant galaxy is another page of cosmic history patiently delivered by light. After a journey almost as old as the universe itself, Carl Sagan once wrote in Cosmos, "We are star stuff, contemplating the stars." Perhaps Nos Sentence captures the feeling of studying the universe's beginning more beautifully. The atoms within our bodies were forged inside stars. Those stars formed from the first clouds of hydrogen. Those clouds emerged within the young universe itself. Whenever we look toward that ancient light, perhaps, in some sense, the universe is remembering its own childhood. Tonight, imagine yourself drifting slowly through that primordial hydrogen mist. Everything is silent. There are no galaxy, no constellation, no familiar sky. Then, far away, the first star ignites, then another, then another. Those tiny points of light slowly pierce the ancient darkness, bringing illumination to a universe that had waited so patiently. Perhaps Every beginning is like that, quiet, unhurried, starting with a single light, which, little by little, changes an entire world. Yet, those first stars did far more than bring light. Within their fiery cores, they forged elements heavier than hydrogen and helium, beginning the long process that would eventually create planets, life, and ourselves. At the same time, within the hearts of many young galaxies, supermassive black holes also began to awaken, releasing enormous amounts of matter and energy, powerful enough to heat the vast regions between galaxies. In the next chapter, we will discover how black holes do far more than consume matter. They become quiet architects of intergalactic space, dispersing heavy elements, heating the cosmic environment, and helping shape the continuing evolution of the universe itself. How black holes reshape intergalactic space. In the previous chapter, we traveled to the dawn of the universe, watching the first stars ignite, bringing about the great epoch of reionization. Now, our story moves forward once again. As the first galaxies gradually emerged, another remarkable character quietly appeared at the centers of many of them. Supermassive black holes, although they are often known as cosmic objects that swallow matter, their influence extends far beyond their own galaxies, reaching deep into intergalactic space. Perhaps when we hear the words black hole, we imagine a bottomless abyss where all light disappears forever, a place that only takes, never gives. Yet once again, nature proves itself far more subtle and astonishing than our first intuition. Black holes do not merely consume matter. During their most active phases, they can also become among the most energetic objects in the universe. Remarkable as it sounds, this follows the ordinary laws of physics. As gas and dust fall toward a supermassive black hole, they do not plunge directly inward. Instead, they spiral rapidly, forming a brilliantly hot accretion disk. Friction and immense gravity raise its temperature to millions of degrees, producing intense radiation across many wavelengths. Sometimes, part of that tremendous energy is focused into two enormous streams of matter launched perpendicular to the accretion disk at speeds approaching the speed of light. Astronomers call them relativistic jets, or simply black hole jets. Seen from a great distance, a galaxy may appear to contain an almost invisible central black hole, yet from its poles, two immense columns of matter and energy extend into space, sometimes stretching hundreds of thousands or even millions of light years, far beyond the size of the galaxy itself. When these jets shine especially brightly in radio wavelengths, their host galaxies are known as radio galaxies, among the most spectacular objects ever observed by radio telescopes. At first, it may seem that black holes are simply releasing energy, yet their influence runs far deeper. These high-speed jets collide continuously with the surrounding intergalactic plasma, stirring the immense seas of hot gas. They heat their surroundings, preventing the gas from cooling too quickly. Astronomers, I know this process as AGN feedback from an active galactic nucleus. Without it, gas inside galaxy clusters would cool much more rapidly, collapse inward, and produce far greater numbers of new stars. Instead, AGN feedback regulates the birth of stars, allowing galaxies to evolve at a very different pace. In other words, a single black hole, tiny compared with its entire galaxy, can influence the evolution of a system spanning hundreds of thousands of light years. It is one of the clearest reminders that in the universe, size alone does not determine influence. Supernova explosions and black hole jets also disperse heavy elements, such as carbon, oxygen, silicon, and iron, into intergalactic space. These elements mix with enormous clouds of gas, waiting for billions of years until they become part of new generations of stars, new planets, and eventually new forms of life. In a very real sense, the atoms inside our bodies have already lived many different lives. Some once existed within the core of a dying star. Some were hurled outward by supernova explosions. Some drifted through intergalactic space before finally joining the young solar system. Carl Sagan wrote in Cosmos, "Nitrogen in our DNA, calcium in our teeth, iron in our blood, carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff." Perhaps few sentences have ever expressed our place in the universe more beautifully. It reminds us that there is no true boundary between humanity and the cosmos. The atoms within our beating hearts once belonged to ancient stars. Those stars were shaped by galaxies. Those galaxies were influenced by black holes, and those black holes helped shape the space between galaxies. Everything is connected through cycles lasting far longer than any human lifetime. Tonight, imagine yourself watching a young galaxy from afar. At its center, a black hole rotates silently, emitting no light of its own. Yet from its poles, two enormous jets stretch outward, slowly, powerfully, illuminating the surrounding cosmos in radio waves and X-rays. Far beyond vast seas of plasma respond with slow, gentle ripples, like the surface of a quiet lake after a single stone has fallen. Perhaps the true wonder of the universe is not found in its greatest explosions, but in the realization that an event occurring at the heart of one galaxy can quietly influence regions millions of light years away. That is the beauty of cosmic connection, never hurried, never loud, yet unfolding patiently across billions of years. And sometimes those invisible connections lead to the most powerful events since the Big Bang itself. No longer a single galaxy, but enormous galaxy clusters colliding, creating shockwaves millions of light years long and revealing some of the deepest secrets of both ordinary matter and dark matter. In the next chapter, we will witness the largest collisions since the birth of the universe, events releasing more energy than almost anything else the cosmos has ever produced, the greatest collisions since the Big Bang. In the previous chapter, we explored how supermassive black holes quietly shape the intergalactic environment. through immense jets of matter and energy. Now, let us broaden our perspective once again, for even the largest galaxies are only small members of enormous galaxy clusters, and sometimes those clusters slowly drift toward one another, creating events that rank among the most powerful collisions since the Big Bang itself. Perhaps, when we hear the word collision, we imagine something sudden, une explosion, un violent impact, a brief moment followed by silence. But in the universe, time has an entirely different meaning. A collision between two galaxy clusters does not last a few seconds, nor a few years. It unfolds over hundreds of millions, sometimes billions, of years. Its motion is so slow that if you could watch it with your own eyes, you would notice almost no change throughout your entire lifetime. Yet hidden within that extraordinary patience lies an amount of energy almost beyond imagination. A galaxy cluster contains far more than galaxies alone. It holds vast oceans of superheated plasma, dark matter, intergalactic gas, and trillions of stars. As two clusters approach each other, most of their galaxies simply pass by without direct collisions. The distances between individual stars are simply too immense, but the hot plasma behaves differently. It collides, compresses, slows, and generates enormous shock waves. Here on Earth, a supersonic aircraft creates shock waves as it moves through the atmosphere. Between galaxy clusters, similar shock fronts form within plasma, heated to tens of millions of degrees. The difference is one of scale. These cosmic shock waves can stretch across millions of light years, carrying more energy than any explosion humanity has ever witnessed. They heat the intergalactic medium, accelerate charged particles, generate radio waves and X-rays, and billions of years later, modern telescopes are finally able to detect their ancient signatures. Perhaps what moves astronomers most deeply is not merely the scale of these collisions, but what they teach us. One of the most famous examples is the Bullet Cluster. Long ago, two galaxy clusters collided. When scientists observed them using different kinds of telescopes, they discovered something extraordinary. The hot plasma, which contains most of the ordinary matter, was slowed and trapped near the collision region because it interacts strongly with itself. Meanwhile, most of the gravitational mass continued forward, almost unaffected. This remarkable separation became one of the strongest observational pieces of evidence that dark matter behaves differently from ordinary matter, not because we observed dark matter directly, but because we observed y gravitationnelle influence even after it separated from the glowing plasma. It was one of those rare moments when the universe seemed to lift a small corner of a mystery that had previously existed only inside equations. Perhaps the greatest beauty of science is not that it always finds answers. It is that every discovery reveals an even deeper mystery. These enormous collisions do not merely destroy, they rebuild. Hot gas is mixed, heavy elements are redistributed, new conditions are created for future galaxies and future generations of stars. In the universe, change rarely carries only one meaning. What appears to be an ending often becomes the beginning of another cycle. Carl Sagan once wrote in Cosmos, "We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology. Perhaps, when we gaze at the night sky, few of us imagine that somewhere immense galaxy clusters are still slowly passing through one another. Shock waves, millions of light years long, continue their silent journey. Dark matter quietly guides the motion of the largest structures in existence. That realization does not make the heavens more frightening, it makes them more wondrous. For beneath the calm appearance of the night sky, nature continues its patient work, following laws that have endured since the earliest moments of cosmic history. Tonight, imagine yourself far away, floating between galaxies. Before you, two enormous galaxy clusters slowly approach. There is no explosion, no blinding flash, only immense clouds of hot plasma gently pressing against one another, sending invisible waves across the cosmos. The galaxies continue their journeys. The stars continue to shine as though they have no awareness that they are participating in one of the greatest events the universe has ever known. Perhaps that is what gives the cosmos its unique feeling, both majestic and peaceful. Even its greatest upheavals unfold with extraordinary patience, never hurried, never chaotic, simply reshaping the universe across billions of years. And after the galaxy clusters gradually separate, something else remains behind. Weak magnetic fields stretching across intergalactic space, ultra-high energy, cosmic rays, nearly invisible, neutrinos, and subtle gravitational waves, continuing their silent journey through the cosmos. In the next chapter, we will explore these invisible messengers, intergalactic magnetic fields, cosmic rays, neutrinos, and gravitational waves, the quiet travelers that carry information from the most distant regions of the universe to humanity. Magnetic fields and the universe's hidden messengers. In the previous chapter, we witnessed the colossal collisions between galaxy clusters and the immense shock waves rippling across millions of light years. Now, let us listen to an even quieter layer of the universe's story. For even after those great motions have settled, the universe has never fallen silent. It continues to send invisible messages, crossing the vastness of space, telling us about places that no spacecraft has ever reached. Perhaps when we look at the night sky, we imagine the space between galaxies to be the quietest place in existence. There is no wind, no sound, no motion our senses can detect. Yet that silence exists only because our eyes and ears are limited. At a deeper level, the universe is filled with invisible streams of information traveling unceasingly across space for billions of years. Among the greatest mysteries are intergalactic magnetic fields. Here on Earth, we are familiar with our planet's magnetic field. It guides a compass needle. It shields our atmosphere from the solar wind. Yet astronomers have discovered that even the extremely diffuse space between galaxies contain magnetic fields. They are extraordinarily weak, almost impossible to measure, yet they extend across millions of light years. To this day, their exact origin remains an open question. Some hypotheses suggest they originated from tiny fluctuations in the early universe. Others propose they gradually strengthened during the evolution of galaxies. Whatever their true origin, their existence reveals that intergalactic space has never been an empty stage. Continuing our journey, we encounter cosmic rays. They are not light, but charged particles carrying enormous energies. Many travel through space at speeds approaching the speed of light. They may originate from supernova explosions, active galactic nuclei, or other extreme phenomena that scientists are still investigating. Every second, millions of cosmic rays strike Earth's atmosphere. Most are slowed or deflected by our atmosphere and magnetic field. We never notice them, yet they are here like silent visitors passing through our world every day. Then there are neutrinos. Physicists sometimes call them ghost particles, not because they are mysterious, but because they interact so rarely with matter. Every second, tens of trillions of neutrinos from the Sun pass through your body, through Earth, and continue their journey almost without leaving. A neutrino could pass through light years of solid lead without colliding with anything. That makes neutrinos among the universe's most extraordinary messengers. They carry information from places where light cannot easily escape. Supernova explosions, the deep interiors of stars, and distant, high-energy events across the cosmos. And perhaps the most remarkable messenger of all is the gravitational wave. In 1916, Albert Einstein predicted that whenever massive objects accelerate, they should produce ripples in space-time itself. Nearly a century later, humanity finally detected them, not with telescopes, but with instruments of astonishing precision. Gravitational waves are not waves traveling through space. They are waves within space-time itself. They are created when two black holes, two neutron stars, or other extremely massive objects spiral together and merge. Einstein once wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." He wrote those words in 1955 in a letter to the family of his close friend, Michele Besso. Perhaps when we think about gravitational waves, their meaning feels even deeper. The ripples we detect today may have originated from events that occurred hundreds of millions or even billions of years ago. What we call the present is sometimes nothing more than the moment un ancien message finally arrives. Perhaps that is the unique beauty of astronomy. We do not merely observe objects, we listen to the messages the universe has patiently been sending all along. Every photon, every neutrino, every cosmic ray, every gravitational wave, each one is a letter written in nature's own language. Tonight, imagine yourself drifting quietly through intergalactic space. There is no sound, no wind, no visible movement, but if you possessed senses that humanity has not yet evolved, you would discover that messages are flowing everywhere. A neutrino passes through you. A cosmic ray races silently across the darkness. A tiny gravitational wave gently ripples through space-time itself. Far away, an almost immeasurable magnetic field patiently connects regions that appear utterly separate. Perhaps the universe has never truly been silent. We are only now learning how to listen. With every new telescope, every new detector, humanity hears another voice of the cosmos, and from all those signals, a clearer picture gradually emerges. The universe is not static. It is not closed. Space itself is expanding, carrying galaxies farther apart, stretching light across the cosmos. In the next chapter, we will explore one of the discoveries that forever changed humanity's understanding of the universe, the expansion of space itself, the phenomenon that stretches light, pushes distant galaxies ever farther away, and turns every cosmic distance into a journey backward through time. The universe is expanding. In the previous chapter, we listened to the invisible messengers that quietly cross the cosmos: neutrinos, cosmic rays, and gravitational waves. Now, let us follow the messenger that is most familiar to us all: light. It was light that led humanity to one of the most profound discoveries in modern science: the realization that the universe is not standing still. The space between galaxies is continuously expanding, carrying them ever farther apart, like leaves drifting along a river that never ceases to flow. Perhaps, in everyday life, we naturally assume that if two objects move farther apart, then one of them must be moving. But on the scale of the universe, something even more remarkable is happening. It is not only the galaxies that are changing position, it is the very space between them. Imagine drawing small dots on the surface of a balloon. As the balloon is inflated, none of the dots moves away under its own power. Instead, the surface itself stretches, increasing the distance between every pair of dots. It is a simple analogy, yet it helps us imagine what is happening throughout the cosmos. Galaxies are not actively fleeing from one another. Rather, the space between them is slowly expanding. One of the earliest pieces of evidence for this expansion came from redshift. When a source of light moves away from an observer, its wavelengths become stretched. The light shifts toward the red end of the spectrum, not because the light itself changes color, but because space itself has stretched. The waves, during their journey, the farther away a galaxy lies, the greater its redshift. It is rather like listening to a familiar melody, played more slowly, where every note becomes deeper. Light, too, carries within it the memory of the path it has traveled. When astronomer Edwin Hubble studied distant galaxies, he discovered an extraordinary pattern. The farther away a galaxy was, the greater its redshift. That simple relationship led to a revolutionary conclusion. The universe is not static, it is expanding. And if the galaxies are farther apart today than in the distant past, they must have been much closer together. That discovery became one of the foundations of the Big Bang theory. Yet perhaps the most remarkable aspect of cosmic expansion is not merely the distances increase, it is the way it transforms our understanding of time itself. In astronomy, distance is almost always another word for time. Light requires time to travel. When we observe a galaxy 1 billion light-years away, we are not seeing it as it exists today. We are seeing it as it was 1 billion years ago. The farther we look, the deeper we see into the past. In that sense, every modern telescope is a kind of time machine, not one that carries people backward through history, but one that brings the history of light to us. Eventually, a time will come when some extremely distant galaxies will recede so rapidly that their light can no longer reach Earth. Cosmologists call this boundary the cosmic horizon. It is not to a wall, not the edge of the universe. Rather, it marks the limit of what light has had enough time to bring to our view. Galaxies beyond that horizon do not cease to exist. They simply fall beyond our ability to observe them, like a ship slowly disappearing beyond the ocean horizon, not because it is gone, but because the distance has become too great. There is a quiet beauty in that thought. The night sky we see today is not a portrait of the present. It is a museum of light. Every star, every galaxy, each one tells a story from a different moment in cosmic history. Edwin Hubble once wrote, "Equipped with his 5 senses, man explores the universe around him and calls the adventure science." Perhaps those words are not only about science, they are also about humanity's natural curiosity. We cannot stop the universe from expanding. We cannot ask light to remain, but we can learn to listen to the messages that light carries across time. And in doing so, we discover that distance is more than space. It is time, memory, history, the unfolding story of a universe that continues to grow. Tonight, imagine yourself standing within intergalactic space. There are no landmarks, no directions. Around you, distant galaxies slowly drift farther away, not because they wish to leave, but because the fabric of space-time itself is stretching. Their light continues its patient journey, yet with every passing year, that journey becomes just a little longer. Perhaps what makes the universe so extraordinary is not merely its immense size. It is that, even while expanding, it preserves within every ray of light the memories of every age that came before. And amid that endless expansion, our own Milky Way does not remain motionless. Together with its neighbors in the local group, it travels through an even greater region of the universe, influenced by galaxy clusters and immense rivers of matter that surround us. In the next chapter, we will return closer to our own cosmic home, exploring the Milky Way's neighbors, discovering how the local group moves within the expanding universe, and understanding our true place within this vast cosmic tapestry. The Milky Way's neighbors. In the previous chapter, we discovered that the universe continues to expand and that every beam of light carries the memory of time itself. Now, let us return a little closer to home, not to leave behind the grandeur of the cosmos, but to realize that even the Milky Way is only another traveler moving through invisible currents that flow across the universe. Perhaps when we gaze into the night sky, it feels as though the Milky Way is standing still. The stars remain where we expect them. The constellations appear unchanged night after night. Yet that stillness exists only within the timescale of a human life. Across millions of years, nothing in the universe is truly motionless. Earth orbits the Sunday. The Sun orbits the center of the Milky Way. The Milky Way travels together with neighboring galaxies inside the local group, and the local group itself participates in an even larger motion. Astronomers refer to it as the local flow. It is not a roi in the ordinary sense, but the collective motion of galaxies guided by the gravitational pull of enormous structures surrounding us. If gravity were visible, perhaps you would see galaxy-like leaves floating gently along en invisible courant. No sound, no waves, only a slow, patient drift, following laws that have existed since the earliest moments of the universe. About 55 million light-years away lies the Virgo cluster, the nearest large galaxy cluster to our own. It contains thousands of galaxies bound together by tremendous gravity. Its gravitational pull influences the motion of many neighboring galaxies, including our own local group. Far beyond that, the Virgo cluster is itself part of an even greater structure, the Laniakea supercluster. The name Laniakea comes from the Hawaiian language meaning immense heaven. It is a beautifully fitting name, suggesting a helm so vast that it almost defies imagination. The Milky Way, the local group, the Virgo cluster, all of them are merely small threads within that immense structure. Perhaps this reminds us that every time we believe we have seen the whole picture, the universe reveals another, even larger one. Surrounding the Milky Way are not only neighboring galaxies, but also the diffuse intergalactic medium, hot gas, plasma, weak magnetic fields, and countless high-energy particles moving silently through space. They form the environment in which our galaxy exists, like a transparent ocean, invisible to human eyes, yet always present, always influencing everything within it. Perhaps the most fascinating neighbor in our cosmic neighborhood is Andromeda. Unlike most distant galaxies, which continue to recede because of the universe's expansion, Andromeda is actually moving toward the Milky Way at a speed of more than 100 kilometers per second. This does not contradict the expansion of the universe. Within the local group, gravity is strong enough to overcome the expansion of space itself. Perhaps that is one of astronomy's most comforting lessons. Even within an expanding universe, there remain places where gravity holds families together like small communities within an endless ocean. Carl Sagan once wrote in Cosmos, "We are a way for the cosmos to know itself." Perhaps each time humanity maps the local group, measures the distance to the Virgo cluster, or studies Andromeda's motion, we are doing more than locating the Milky Way. We are gradually discovering where we truly belong, within the universe. Not at the center, not en exception. Simply a very small part, yet one that can never be separated from the whole. Tonight, imagine yourself far enough away to see both the Milky Way and Andromeda as two immense rivers of light. Farther still, the Virgo cluster appears as a faint glow. Farther again, the entire Laniakea supercluster resembles a vast network drifting quietly through space. Nothing is truly motionless. Nothing is completely isolated. Every motion is connected by gravity, by time, and by 13.8 billion years of shared history. Perhaps that is what makes the night sky feel so peaceful, not because the universe is still, but because even its greatest motions unfold with extraordinary patience, gentle, orderly, and timeless. Yet Andromeda's approach will not continue forever. In about 4 to 5 billion years, the two great galaxies will finally meet, not like two cars crashing together, but like two luminous rivers slowly merging under gravity's patient guidance. In the next chapter, we will witness the future encounter between the Milky Way and Andromeda, discovering why hundreds of billions of stars are unlikely to collide, yet why the night skies of future worlds will be changed forever. The future collision. But in the previous chapter, we discovered that Andromeda is not drifting away from the Milky Way like most distant galaxies. Instead, it is slowly moving toward us under the gentle pull of gravity. Now, let us journey farther into the future, not centuries, nor millions of years, but roughly 4 to 5 billion years from now. That is when these two giant galaxies will finally meet in an event that will completely transform the appearance of the night sky, while unfolding in almost perfect silence. Perhaps, when we hear the phrase galactic collision, the first images that come to mind are violent explosion, stars crashing together, and unimaginable destruction. Yet once again, the universe chooses a gentler story. The Milky Way contains hundreds of billions of stars. Andromeda contains a similar number. At first, it seems inevitable that countless stars must collide, but reality is remarkably different. The distances between stars are almost impossible to imagine. If our sun were no larger than a grain of sand, the nearest star would still be hundreds of kilometers away. Within such an extraordinarily empty space, the chance of two stars striking one another is exceedingly small. What truly happens is not a collision between stars. Instead, gravity begins to reshape the entire structure of both galaxies. Their spiral arms, their clouds of gas and dust, their star clusters, everything is gradually stretched, twisted, and drawn outward, forming enormous rivers of stars, hundreds of thousands of light years long. These graceful structures are known as tidal tails, vast ribbons of light, woven by gravity itself. If you could watch the entire event as a time-lapse movie, you might never think you were witnessing a collision. It would resemble two magnificent ribbons of light slowly flowing into one another. Each graceful turn would require hundreds of millions of years. Every transformation would unfold with extraordinary patience. Only when viewed through the immense clock of cosmic time does its true magnitude become apparent. During this process, some star systems will find themselves in new orbits. Some stars will be flung far from their original homes. Others will drift closer to the center of the newly forming galaxy. Meanwhile, gas and dust will be compressed, triggering intenser regions of star formation. Entire generations of young stars will be born, even as older structures gradually disappear. This is not complete destruction. It is a profound reorganization, a new chapter written upon the foundation of the old. Supercomputer simulations suggest that after billions of years, the Milky Way and Andromeda will most likely merge into a single, larger galaxy. Astronomers sometimes refer to it informally as Milkomeda, a blend of Milky Way and Andromeda. Although it is not an official astronomical name, it beautifully captures the idea that even galaxies continue writing their stories by becoming part of something new. If a distant civilization still exists to observe the sky, at that time, its heavens will look entirely different. New rivers of stars will stretch across the sky. The galactic center will glow more brilliantly. Young star clusters will sparkle throughout the heavens. The familiar night sky, known to humanity today, will have become only a distant memory. Perhaps what makes this event so extraordinary is not its scale, but the way it unfolds. No sound, no urgency, no single instant that can truly be called the beginning or the end. Only gravity, patient, silent, and unhurried, reshaping everything over billions of years. Carl Sagan wrote in Cosmos, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." Perhaps when we imagine the future meeting between the Milky Way and Andromeda, those words become even more meaningful. The atoms that compose our own bodies may still exist. When those galaxies finally unite, they may become part of new stars, new planets, and perhaps someday new forms of life. In the universe, nothing truly disappears. Everything simply continues to change its form. Tonight, imagine yourself standing upon a distant world. Above you, the Milky Way no longer shines. Alone, Andromeda appears larger with every passing age. Across millions of years, the two rivers of light slowly approach. Their spiral arms begin to overlap. Long streams of stars unfold like silver ribbons across the heavens. There is no explosion, no fire, only light, gravity, and time, together painting one of the most magnificent scenes the universe will ever create. Perhaps it reminds us that even the greatest transformations need not arrive through chaos. Sometimes nature creates its greatest masterpieces through patience, almost beyond imagination. And as the two great galaxies gradually become one, the countless dwarf galaxies surrounding them continue their own stories. Some will be stretched into stellar streams, Others will donate their gas to future generations of stars. Together, they ensure that the universe never ceases to renew itself. In the next chapter, we will explore dwarf galaxies and the recycling of cosmic matter, discovering how the smallest members of the universe often play the greatest role in nurturing the galaxies and stars of the future. Dwarf galaxies and the recycling of matter. In the previous chapter, we imagined the distant future when the Milky Way and Andromeda slowly merge. During a meeting lasting billions of years, now let us turn our attention to much smaller characters. In the universe, the largest structures are not always the ones that tell the most important stories. Sometimes it is the quiet, humble dwarf galaxies orbiting their giant companions that preserve the memories of the past while planting the seeds of the future. Perhaps, if asked to choose a galaxy to observe, most of us would choose a magnificent spiral galaxy or a giant elliptical galaxy. Few people would notice the dwarf galaxies. They are far smaller, far dimmer, containing only a tiny fraction of the stars found within the Milky Way. Yet to astronomers, these modest systems are among the most valuable pieces of the cosmic puzzle. Many dwarf galaxies contain very few stars. Some appear to be dominated almost entirely by dark matter. The visible matter accounts for only a small fraction of the gravity they produce. For that reason, some astronomers describe them as dark dwarf galaxies, not because they are completely invisible, but because most of their mass does not emit light. For billions of years, these dwarf galaxies have orbited larger galaxies, such as the Milky Way. Yet, the immense gravity of their giant hosts never stops, acting upon them very gently, very slowly, but without pause. Over time, the dwarf galaxies begin to stretch. Stars gradually drift away from their original structures, forming long stellar streams that wrap around their larger companions. These are the faint signatures astronomers continue to observe today, like faded brushstrokes remaining upon an ancient painting. They preserve the memory of encounters that occurred billions of years ago. Nor are stars the only things to be drawn away. Gas within these dwarf galaxies can also be pulled outward by gravity. Between galaxies, immense bridges of matter begin to form. Astronomers call these structures tidal bridges. If they were visible to the naked eye, perhaps they would resemble delicate ribbons connecting two islands of light across a cosmic sphere. Graceful, beautiful, yet shaped by gravitational force, powerful enough to alter the destiny of entire galaxies. Perhaps the most remarkable part is that this displaced gas does not always disperse forever. In many cases, it gradually cools, contracts, and eventually forms new stars far beyond the familiar boundaries of galaxies. This means that stars need not be born only within the heart of a galaxy. Even intergalactic space, given enough gas and suitable conditions, can become a birthplace of light. There is something deeply beautiful. In that thought, it reminds us that starlight always seems to find a way to continue even after events that appear to bring only loss. Today, astronomers increasingly view the intergalactic medium not as empty space, but as a vast cosmic nursery, to a place where gas is exchanged, matter is recycled, and future generations of stars are quietly prepared. In nature, there is no absolute boundary between endings and beginnings. A dwarf galaxy may be torn apart, yet its atoms continue their journey. They become part of new clouds of gas, new stars, new planets, and perhaps, someday, new living worlds. Carl Sagan wrote in Cosmos, "The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of stars. We are made of star stuff." Perhaps, when we read those famous words, we naturally think of stars. Yet behind every generation of stars lie dwarf galaxies, tidal bridges, vast clouds of gas, and cycles of renewal lasting billions of years. Every atom within us has traveled far longer than any story humanity has ever told. Tonight, imagine yourself floating quietly through intergalactic space. In the distance, our dwarf galaxy is slowly being stretched into a delicate ribbon of light, not because it is disappearing, but because it is sharing its matter with the universe. Farther away, a cloud of gas has cooled just enough to begin collapsing. Then, a tiny point of light appears. A new star has just been born in a place once believed to be empty. Perhaps that is what gives the cosmos its quiet hope. In nature, no loss is ever completely meaningless. Every ending can become the beginning of something new. Every atom continues its journey, and every place that appears empty may one day become the cradle of light. Yet even as dwarf galaxies help create future generations of stars, astronomers have discovered an unsteigender kind of galaxy, immense systems, so faint that they are almost invisible, where dark matter appears to dominate almost completely. In the next chapter, we will explore the mysterious world of ultra-diffuse galaxies and discover that sometimes the hardest structures to see are the ones holding the universe's greatest secrets. Invisible galaxies. In the previous chapter, we explored how dwarf galaxies quietly help recycle matter and plant the seeds of new stars throughout intergalactic space. Now, let us venture deeper into one of the most intriguing mysteries of modern astronomy. There are galaxies that stand before our telescopes, yet are so faint they are almost overlooked. They spread across space like giant galaxies, but emit only the faintest glow, as though most of their true nature lies hidden behind an invisible veil. Perhaps, in everyday life, we naturally assume that the larger something is, the easier it should be to see. A mountain stands out more than a stone. An ocean is easier to notice than a stream. But the universe does not always follow our intuition. Among the millions of galaxies that have been discovered, there exists a remarkable class known as ultra-diffuse galaxies. What makes them so extraordinary is that many are nearly the same size as the Milky Way, yet contain far fewer stars. Their stars are spread thinly across space. Their light is diffuse, so faint that if one were much farther away, we might never realize it existed at all. At first glance, an ultra-diffuse galaxy looks almost like a delicate mist. No brilliant spiral arms, no dazzling star-forming regions, only a pale glow drifting quietly through the darkness. Yet it is precisely this faintness that has inspired so many questions among astronomers. If so few stars inhabit these galaxies, what keeps them from falling apart? The answer, at least according to current observation, leads us back to a familiar character: dark matter. When astronomers measure the motion of stars inside many ultra-diffuse galaxies, they find that those stars move far faster than the visible matter alone can explain. This suggests that most of the galaxy's mass does not lie within the stars we can see, but within something entirely invisible: dark matter. In some cases, the amount of dark matter appears so overwhelming that the stars look like tiny specks of glittering dust floating inside an enormous gravitational structure. If that picture is correct, then everything we observe is only a thin outer layer surrounding the true substance of the galaxy. Perhaps this is one of astronomy's most beautiful lessons. Light does not always tell the entire story. Some of the most important things do not shine. They do not announce their presence, yet they quietly shape the architecture of the universe. Today, astronomers continue to debate the origins of ultra-diffuse galaxies. Some hypotheses suggest they began as ordinary galaxies, but their star formation ended very early. Others propose that they formed inside unusual halos of dark matter where conditions were never ideal for creating large numbers of stars. So far, no single explanation has emerged, and perhaps that uncertainty is exactly what makes them so fascinating. Every ultra-diffuse galaxy serves as a natural laboratory, helping us to better understand dark matter, galaxy formation, and the many mysteries that still lie beyond our current knowledge. Astronomer Vera Rubin, whose pioneering work provided some of the strongest evidence for dark matter, once said, "Science progresses best when observations force us to alter our preconceptions." Perhaps no quotation captures these ghostly galaxies more perfectly, because they have compelled scientists to reconsider ideas that once seemed settled. A galaxy does not have to be bright. A galaxy does not have to contain countless stars, and the true source of its mass may be something completely invisible. Tonight, imagine yourself drifting quietly through intergalactic space. Far away, a faint galaxy slowly appears, so delicate that it almost melts into the darkness. If you relied only upon your eyes, you might believe that almost nothing was there. But if you could feel gravity, you would discover an immense mass holding those scattered stars together. No brilliant light no vivid colors, only the silent presence of something humanity has not yet fully understood. Perhaps that is what makes the universe so endlessly captivating. The more we discover, the more we realize that its greatest wonders are often the hardest to see, not because they are hiding, but because nature is always greater than our ability to observe it. And from these almost invisible galaxies, astronomers have discovered an even more remarkable tool for studying the unseen matter of the universe. It is a phenomenon where gravity itself can bend light, transforming an entire galaxy cluster into a gigantic natural telescope. In the next chapter, we will explore gravitational lensing, a phenomenon that allows humanity to see galaxies far beyond the reach of even our greatest telescopes, while revealing yet more precious evidence for the existence of dark matter. Gravitational lensing. In the previous chapter, we explored the mysterious ultra-diffuse galaxies, where most of the mass appears to be composed of invisible dark matter. Now, and let us continue into an even more remarkable phenomenon, one that reveals that space itself is not merely the stage upon which galaxies exist. Space can bend, it can curve, it can redirect light, becoming an immense telescope created by nature itself. Perhaps throughout our daily lives, we assume that light always travels in straight lines. A beam is emitted and continues forward. That is true, however, only if space itself is perfectly flat. According to Albert Einstein's general theory of relativity, mass does not simply produce gravity. It also curves the very fabric of space-time. And when space-time bends, light, which always follows the straightest possible path through that curved geometry, change direction as well. Not because light is pulled like an object with mass, but because the road it travels upon has itself been curved. At first, this idea sounded almost like science fiction, but in 1919, during the famous solar eclipse expedition led by Arthur Eddington, astronomers measured the apparent positions of stars near the Sun and found them shifted by exactly the amount Einstein had predicted. It became one of the defining moments in the history of science when a bold idea about the nature of space was confirmed through observation. Today, this phenomenon is known as gravitational lensing. Imagine that between us and a distant galaxy there lies a massive galaxy cluster. The immense gravity of that cluster curves space-time. As light from the distant galaxy passes nearby, its path is bon. The result is extraordinary. The background galaxy may appear brighter, larger, or stretched into beautiful arch of light. Sometimes a single galaxy appears multiple times across the sky, not because there are many galaxies, but because the light from one galaxy has traveled along several different paths before reaching Earth. Just as a glass magnifying lens can enlarge tiny words, a galaxy cluster, through gravity alone, can magnify the light of galaxies more than 13 billion light-years away. There is something wonderful about that thought. The universe has built its own telescope. Thanks to gravitational lensing, astronomers have observed galaxy. It formed when the universe was still very young. Galaxy too distant and too faint to be seen even by our most advanced telescopes without nature's assistance. In that sense, gravitational lensing does more than help us see farther. It allows us to look deeper into the past. Every luminous arc, every distorted image carries a message from the earliest chapters of cosmic history. Even more remarkably, this phenomenon helps scientists map dark matter because the amount of bending depends upon the total mass of a galaxy cluster, including the invisible matter that emits no light. By carefully studying the shapes of these arcs, astronomers can infer where dark matter is concentrated, despite never observing it directly. Perhaps this offers one of the most beautiful examples in science. Sometimes we understand something not by looking directly at it, but by observing the influence it leaves upon the world around it. Albert Einstein once wrote, "The most incomprehensible thing about the universe is that it is comprehensible." Perhaps that is exactly how many astronomers feel when studying gravitational lensing, a phenomenon that seems almost magical, yet can be described by mathematics, confirmed through observation, and ultimately used to extend the boundaries of human understanding. Once again, tonight, imagine yourself standing far out among the galaxies. Before you lies a massive galaxy cluster. Far beyond it, a young galaxy has only just begun to shine. Its light does not travel in a straight line. Instead, it slowly curves around the cluster like water flowing gently around a stone in a stream. Then, after billions of years, a tiny fraction of that ancient light finally reaches Earth, where curious minds patiently gaze toward the heavens. Perhaps what makes gravitational lensing so beautiful is not merely that it allows us to see farther. It reminds us that even space, which seems so completely empty, can itself become a storyteller. Every bent ray of light speaks of invisible mass, ancient galaxies, and the earliest chapters of the universe. Yet the journey of discovery is far from complete. To fully understand the cosmic web and its hidden filaments, humanity will need even more powerful eyes, the next generation of telescopes. In the next chapter, we will explore the future of astronomy, where new observatories will map the cosmic web with unprecedented detail and continue the search for the unseen matter that still remains beyond our direct view, the future of astronomy. In the previous chapter, we explored how gravity can bend light itself, transforming entire galaxy clusters into vast natural telescopes. Now, let us turn our gaze toward the future. Not the future of galaxies, but the future of humanity's journey to understand the universe. For remarkable as our discoveries have been over the past century, astronomers believe that most of the story of the cosmos still remains to be told. Perhaps one of the most beautiful things about science is that every answer opens the door to even more questions. For centuries, humanity has continued to build larger, more sensitive, and more precise telescopes. From the first small instruments crafted by Galileo Galilei to observatories perched atop remote mountain peaks, and finally to space telescopes such as Hubble and James Webb, each new generation has opened a doorway that never existed before. What is especially fascinating is that astronomers no longer wish only to observe more galaxies. They also want to observe the vast spaces between them, because those regions, which once appeared completely empty, actually contain most of the universe's ordinary matter. One of the greatest goals of modern astronomy is to create a complete map of the cosmic web. We already know that this immense network exists. We have observed many of its filaments. We have simulated their formation, yet the picture remains incomplete. Like an ancient map, there are still regions marked simply unexplored. The gigantic filaments that connect galaxy clusters are almost certainly far more common than the ones we have already detected. But because they are so diffuse, so faint, direct observation remains an enormous challenge. That is why the next generation of observatories, optical, radio, and X-ray, is being designed to achieve greater sensitivity than ever before, not simply to see farther, but to reveal more clearly what has always been there. There is something deeply remarkable about this. Based on our current understanding, most ordinary matter has already been inferred through multiple methods of observation, yet not all of it has been observed directly in every form. In particular, the extremely diffuse gas threading the cosmic web remains an active focus of observation, mapping, and increasingly precise measurement. That does not mean science lacks answers. Quite the opposite. It demonstrates that science is always willing to test, to observe, and to refine its understanding. Perhaps that is exactly what makes our exploration of the universe so beautiful. Not because we already know almost everything, but because we remain humble enough to admit how much still remains unknown. Carl Sagan once wrote, "In Cosmos, somewhere, something incredible is waiting to be known." Perhaps those words have never grown old, because every time a new telescope begins its work, another opportunity appears for what seems invisible today to become understood tomorrow. Somewhere within the cosmic web, there may still be filaments never before detected, clouds of gas never mapped, extremely faint galaxies still undiscovered, or entirely new laws of nature that humanity has yet to imagine. These are not gaps in knowledge, they are invitation for future generations. Tonight, imagine yourself standing beside a telescope of the future, larger than any observatory ever constructed. It is not merely watching the stars, it quietly gathers the faintest whispers from empty space. Every photon, every X-ray, every radio wave, patiently assembled piece by piece, like fragments of an enormous puzzle. Year after year, the map of the cosmic web becomes more complete. Dark regions gradually emerge, empty spaces gain names, and humanity understands just a little more about the place it calls home. Perhaps that is the unique beauty of astronomy, not conquering the universe, but learning to listen to it, not rushing toward every answer, but moving patiently, one careful step at a time, allowing each discovery to rest upon carefulness, honesty, and curiosity, because it is that curiosity which has carried humanity from wondering about tiny points of light to mapping structure billions of light years across. Yet after everything we have learned about matter, light, and space, an even greater question still remains. What truly determines the destiny of a galaxy? Not only its own mass, but also the invisible environment surrounding it. In the next chapter, we will discover why the space between galaxies is not merely the backdrop of the universe, but the quiet force that helps determine whether a galaxy continues forming new stars, flourishes brilliantly, or gradually enters the peaceful silence of cosmic old age. Intergalactic space shapes the destiny of galaxies. In the previous chapter, we looked toward the future of astronomy following humanity's effort to map the hidden filaments of the cosmic web. Now, as our journey draws closer to its conclusion, perhaps it is time to return to a question that appears simple, yet maybe the most profound of all. What truly determines the fate of a galaxy? Is it merely its own mass, or is there a quieter character working silently behind the scenes, guiding its entire story? Perhaps, for many years, humanity imagined galaxies as isolated islands, each containing hundreds of billions of stars, gas, dust, immense molecular clouds, and it seemed that everything important happened within their boundaries. Yet the more astronomers observed, the clearer one remarkable truth became. To understand a galaxy, it is not enough to study the galaxy alone. We must also understand the space surrounding it. The intergalactic medium, once dismissed as empty science space, quietly influences the destiny of systems hundreds of thousands of light years across. A galaxy can continue forming new stars only if it possesses cold gas. That gas provides the raw material for molecular clouds to collapse under gravity, igniting new suns. But when a galaxy travels through a dense intergalactic environment, especially within a galaxy cluster, pressure from the surrounding hot plasma can gradually strip away its gas. As we encountered earlier, this process is known as ram pressure stripping. It does not happen in an instant. It unfolds over hundreds of millions of years, slowly, patiently, until the galaxy no longer retains enough gas to continue building new stars. The older stars continue to shine, but each generation of young stars becomes smaller than the last. The galaxy does not die immediately. It simply grows quieter, like an ancient forest where no new saplings take root. Beyond the loss of gas, The intergalactic environment also influences how rapidly a galaxy evolves. Galaxies living within less crowded regions often retain their gas for much longer, allowing a star formation to continue across immense spans of cosmic time. By contrast, galaxies deep inside massive clusters experience more gravitational encounters, more interactions, and more rapid gas loss. They grow old more quickly, not because they are weaker, but because their surroundings are fundamentally different. Today, astronomers no longer regard intergalactic space as merely the background of the cosmic picture. Instead, they see it as an active participant in cosmic evolution. Hot plasma, filaments, magnetic fields, diffuse gas. Each contributes to the story of every galaxy in quiet yet profound ways. Perhaps the simplest image is this: intergalactic space is to galaxies what the ocean is to ships. Every ship has its own shape, its own sails, its own destination, yet the currents, the tides, and the waves still help determine how quickly it travels, how far it reaches, or whether it must slow down. Of course, this is only an analogy, not a physical law, yet perhaps it offers a gentle way to imagine the importance of cosmic environments. Carl Sagan once wrote, "In cosmos, we are a way for the cosmos to know itself." Perhaps as we approach the end of this journey, those words take on an even deeper meaning, because what humanity has discovered is not only galaxy, nor stars, nor dark matter, but the intricate connections between them all. A galaxy cannot be understood apart from its environment, just as a star cannot be understood apart from the galaxy that gave it birth. And perhaps it is precisely those invisible relationships that reveal the universe's greatest beauty. Tonight, imagine yourself standing far beyond our own galaxy, watching a graceful spiral galaxy turning slowly through space. Ahead of it, an ocean of hot plasma drifts quietly past. Farther away, vast filaments connected to neighboring dark galaxy clusters. Nothing moves quickly, nothing makes a sound, yet every tiny stream of gas, every subtle pull of gravity is quietly writing the future of that galaxy. Perhaps that is what makes intergalactic space so extraordinary. For centuries, humanity called it empty. Then science revealed that it never was. It is where matter flows, where galaxies exchange gas, where ancient signals cross billions of light years, where light travels through time to tell the history of the universe, and where, almost invisibly, the growth, aging, and renewal of galaxies are quietly decided. After everything we have explored together, only one final question remains. If the space between galaxies has never truly been empty, what does that tell us about the universe itself? In the final chapter of our journey, we will look back upon everything we have discovered and realize that emptiness was never truly empty. It is the invisible framework of the cosmos, the place where history is preserved, where evolution is nourished, and where every galaxy is joined together within a magnificent symphony that has echoed across nearly 13.8 billion years. Empty space was never empty. If, at the beginning of this journey, we started with a very simple question whether the space between galaxies is truly empty, then now, after traveling together through billions of years of cosmic history, perhaps the answer has quietly revealed itself. That emptiness was never truly empty. It is a vast world, silent, subtle, and more extraordinary than humanity ever imagined. And perhaps it is precisely that profound silence which tells the greatest story of the cosmos. Perhaps the most beautiful gift astronomy offers us is not its numbers, not distance, measured in billions of light years, nor the breathtaking images captured by powerful telescopes, but the gentle way it changes how we see the world. When we began this journey, the space between galaxies seemed like nothing more than darkness, a quiet pause between islands of light. But the farther we traveled, the more we realized that darkness was never truly empty. There is hydrogen, there is helium, there are oceans of plasma, millions of degrees hot. There are faint magnetic fields stretching across millions of light years. There are neutrinos silently crossing the universe. There are cosmic rays carrying energy from the most distant places. And there are gravitational waves quietly rippling through the very fabric of space-time. Together, we have witnessed the enormous filaments that weave galaxy clusters into the vast cosmic web, the immense voids that appear almost empty, yet help shape the entire structure of the cosmos. We have journeyed through oceans of hot gas, brillant quasars, ghostly galaxies, gravitational lens, black holes, collisions lasting billions of years, and tiny dwarf galaxies silently passing their matter to future generations of stars. Each story, at first, seemed completely different, yet in the end, they all led to the same truth. Nothing in the universe exists alone. Every galaxy is connected, not only through gravity, but through the flow of matter, through light, through time, and through a shared history that began with the Big Bang. Perhaps what moves us most is not that the universe is unimaginably vast, but that the more we understand it, the more we realize that we belong to it. The atoms within our bodies once lived inside ancient stars. Those stars were born from primordial clouds of hydrogen. Those clouds were guided by invisible structures stretching across the cosmos. Astronomer Carl Sagan once wrote one of the most beautiful lines in Cosmos: "We are star stuff contemplating the stars." Perhaps, after everything we have explored together, those words carry an even deeper meaning. We are not only made of stardust, we are also the result of intergalactic gas, of exploding supernovae, of colliding galaxies, of black holes that stirred the cosmic seas, and of light that patiently traveled for billions of years to bring those stories to humanity. Strangely enough, while people often fear emptiness, the universe uses emptiness to create everything The space between galaxies is not merely the framework of the universe. It is a library of history, a highway for matter, the path along which the elements journey across the cosmos, the cradle of future stars, the place where galaxies meet, drift apart, evolve, and continue their stories. Perhaps that is also a gentle reminder for each of us that what appears empty sometimes contains the deepest meaning within the quiet spaces of our lives. Changes may already be unfolding, even if we cannot yet see them. Within the most ordinary days, something beautiful may quietly to be taking shape. Nature never hurries, neither does the universe. Every galaxy grows over billions of years. The cosmic web was woven from tiny fluctuations. Even the first stars once began as delicate clouds of gas. Perhaps patience itself is the greatest lesson the cosmos offers us tonight. As the sky outside your window grows still, perhaps you will look upward and notice only a handful of tiny stars. But now, you know, behind those small points of light lays a network stretching billions of light years, invisible oceans of plasma, rivers of matter that have never stopped flowing, galaxies being born, growing old, colliding, and continuing to write the story of the universe. Perhaps empty space was never empty. It is where galaxies to begin, where time keeps its memories, where light travels, where the universe's greatest mysteries still wait patiently for humanity to discover them. And perhaps the greatest wonder of the universe is not what we already know, but everything still waiting for us to look up, to ask one more question, and to continue the endless journey of discovery. And now, our journey tonight is slowly drawing to its final moments. Perhaps when you first pressed play, you were simply looking for something gentle to listen to before drifting off to sleep. But then, one story after another, one ancient ray of light after another, one distant galaxy after another quietly carried us farther than we ever expected. Together, we left the Earth, crossed the Milky Way, passed through immense galaxy clusters, drifted across oceans of plasma, millions of degrees hot, gazed at brilliant quasar near the edge of the observable universe, followed streams of matter weaving billions of galaxies into one enormous cosmic web, listened to gravitational waves rippling gently through space-time, and finally we returned, only to realize that the place we once called empty space has always been one of the most vibrant places in the entire universe. There is something beautiful about that. The more humanity understands the universe, the more humble we become. Every new telescope, every space mission, every discovery brings not only answers, but countless new questions. Perhaps that is the true beauty of science, not knowing everything, but remaining curious, remaining open to wonder, and remaining patient enough to keep searching. Throughout these past 2 hours, we have spoken about galaxies, black holes, clouds of gas, and stars. But if we look carefully, perhaps the entire story has always been about one thing: connection. No galaxy is ever truly alone. No beam of light travels without meaning. No atom remains still forever. Everything is moving. Everything is exchanging. Everything is helping create a picture far greater than itself, and perhaps that changes how we see our own lives. Sometimes the quiet seasons are not the end of the story. They are simply the space needed for something new to begin, just like the space between galaxies. At first glance, it seems silent, empty, still, yet it preserves matter, history, light, and nourishes the future of the entire universe. Perhaps within each of us there are, en space, just like that, quiet seasons, ordinary days, moments when we are simply alone with ourselves. And perhaps those are the moments when the soul is quietly healing, quietly growing, quietly preparing for another journey. Carl Gustav Jung once wrote, "Who looks outside dreams, who looks inside awakes." Perhaps after looking so far into the universe, together, the greatest gift we receive is the chance to look a little deeper into ourselves, because every time humanity explores the heavens, it is also a journey into the mind. Every mystery of the cosmos reflects a small part of the mystery within ourselves. Perhaps that is why looking up at the night sky so often brings a quiet sense of peace, not because we have discovered all the answers, but because we have learned to accept that there will always be things beyond our understanding, and somehow that is perfectly okay. Tonight, as your eyes grow heavier, perhaps you can imagine that somewhere far beyond our little world, the galaxies continue to turn. New stars are still being born. Ancient rays of light are only now beginning their journeys that will last billions of years. Black holes continue to quietly shape the space around them. Rivers of gas still drift through the vast cosmic web. Everything continues, slowly, gently, following the same rhythm that nature has preserved for nearly 14 billion years. And while the universe continues its endless story, perhaps tonight you can allow your own story to pause for a little while. There is no need to solve every problem before you sleep, no need to carry every thought from a long day into the night. Tomorrow, the sun will rise again. A new morning will quietly arrive. But for now, the only thing that truly matters is one slow breath, a body completely relaxed, and a mind becoming a little quieter with every passing moment. If tonight's journey has brought you even a small sense of peace, a spark of curiosity, or simply helped you feel a little more relaxed before sleep, then that is the greatest gift you could ever give to our channel. If you enjoy these gentle stories about the universe, science, philosophy, and the hidden mysteries of the human mind, we would be honored to have you join us. Please take a quiet moment to subscribe, turn on notifications, and continue exploring with us. Every week, we'll set out on another journey, perhaps to the deepest corners of the universe, perhaps into the mysteries of the human brain, perhaps through the timeless ideas of Carl Gustav Jung, or perhaps simply into stories that help the mind grow still after a long day. Thank you for spending this time with us. Thank you for looking up at the stars together, and thank you for discovering the beauty hidden within the things that so often appear invisible. Now, our journey comes to its gentle end. Let the stars continue telling their stories. Let the universe continue moving to its own quiet rhythm, and let your mind finally rest. May your night be peaceful. May your sleep be deep and restorative. And may you wake tomorrow with a lighter heart, a clearer mind, and a deeper sense of wonder for the vast universe that we are all so fortunate to call our home. Good night, sleep well, and until our next journey, may the stars watch over your dreams.